Alright guys, welcome back. So, today we are going to be taking a look at our next section notes, which is 10.2, arcs and chords. So, let's take a look here for our very first part. A lot of vocab, okay, to start off with. This entire chapter is about circles, so you're going to be hearing tons and tons of vocab. So here we go. In a plane, an angle whose vertex is the center of a circle is a central angle of the circle. So if I draw myself a circle, if you create an angle with the center point being the center of, or the vertex of the angle being the center of the circle, this is known as a central angle. Okay, it's in the center, central of the circle. If the measure of a central angle, angle APB, is less than 180 degrees, then A and B are the points of circle P, and the interior of angle APB form a minor arc of the circle. So here's an example. Up top here, or I'll even draw another one for you. APB. Here's A, here's P, here's B. If this is less than 180, right here, okay, meaning a straight line, less than a straight line, this would be known as a minor arc. Meanwhile, a major arc would be one that goes all the way around. Okay, so here, A, P, B, where it's rotating all this way, this would be a major arc. Okay, so major would be anything over 180 degrees. If the endpoints of an arc are the endpoints of a diameter, then the arc is a semicircle. So you guys know what a semicircle is. If I draw a line straight through, there's a semicircle, okay? The measure of a minor arc is defined to be the measure of its central angle. So a minor arc is whatever this middle angle is equal to. So for example, here, this is roughly about 120 degrees, so the minor arc itself would be 120 degrees. The measure of a major arc is defined as the difference between 360 degrees and the measure of its associated minor arc. So back to this example, if I want to find the other arc, and I knew this was 120, I could just do 360 minus 120 to get my other arc. Okay? So we're going to be using 360 a lot with circles, which makes sense. Lastly, two arcs of the same circle or of congruent circles are congruent arcs if they have the same measure. So if they have the exact same measure, we have congruent arcs. So let's take a look at number one here. Find the measure of each arc of circle C. AD. Okay? Pretty simple, it's kind of given to you, but AD would just be 120 degrees. Very good. Now, ADB, you follow the direction, ADB, all the way across. See how this is a straight line? And it's a straight line, the associated arc would be 180 degrees, half of 360. DBA. D starts here, then B, then A. So it's everything on this circle except for 120. So 360 minus 120, 240 degrees. Lastly, BD. Okay, and maybe some of you guys are wondering too, like, how do I know if I go this way or maybe all the way around? You always want the shortest distance, unless there's 3 letters. So for BD, it's from here to here. I know this is 180. This is 120. So 180 minus 120, 60 degrees. I forgot to box all these answers off. Okay? Wonderful. So here we go. We've got some more postulates and some theorems to take a look at. Postulate 26, arc addition postulate. The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So back over to here. Okay, if I know this one and this one, if this is 120 and 60 degrees, if I add them together, I get my big arc. It's kind of like your angle addition postulate and your segment addition postulate from earlier in the year. Theorem 10.5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So DE is congruent to EF. Okay, so it's congruent right there. And also DG is congruent to GF. Arc DG is congruent to GF. So these arcs are going to be the same measure as well. Alrighty? So they are associated. Okay, on to the back. Theorem 10.6. If one chord is a perpendicular bisector of another chord, and the first chord is a diameter. Now, this is basically kind of the converse here. If you have a chord that's cut in half and is perpendicular, then this line going across, this JK, it must be diameter. Okay? It must cut straight through the middle of your circle. Theorem 10.7. In the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So I have chord AB, I have chord CD, and they're going to be congruent if they are the same exact distance to the center. Okay, like if I draw a perpendicular line from the center to the chords, they're the same distance. Alrighty? So, wonderful. Now we're going to take a look at a bunch of practice. Find the measure of arc Km using theorem 10.5. So theorem 10.5 says that if this is perpendicular, okay, bisects it, these arcs are going to be the same. So I'm making an equation. 7x minus 16 equals 5x. Okay, I'm going to add 16 to the right. So 7x equals 5x plus 16. I'm going to subtract 5x from both sides. And divide by 2. X equals 2. Or x equals 8, sorry. Alright? Much the same here for number 2. Same idea. I can set these 2 arcs equal to each other. 7x can equal 3x plus 24. Get x by itself. Subtract 3x from both sides. 4x equals 24. Divide both sides by 4. X equals 6. Okay? Alrighty. Now, on to the very last part. This is actually like the easiest part, I feel. 1 through 8. Determine whether the arc is a minor, major, or semicircle. AE. So from here to here. Right? Always the shortest distance. It's less than a straight line, less than a semicircle, therefore it's minor. Number 2, AEB. Notice it goes all the way around, straight line. This would be your semicircle. FDE, starting, going here, all the way across, another straight line. Here is your semicircle again. DFB, we have DFB. Notice this goes past a straight line. This is known as a major arc. FA, from F to A, real simple, real short, minor. BE, simple, short, minor. BDA, BDA, all right. It's just, again, going up this way, same thing as AEB earlier. This is a semicircle. And lastly, FB, real short, again, minor. Typically, maybe you've noticed this, the 2 letters are normally minors. The 3 letters are going to be either your semicircle or major. It won't always be that case, but for the most part, you do run into that a lot. Okay, last part of the notes. Thanks for bearing with me. MQ and NR diameters, find the indicated measures. Well, we're going to do a little bit of sleuthing here. If this is 70 degrees by vertical angles, this must also be 70 degrees. Now, hopefully you guys can see this is a straight line right here. Straight line, this is 70 and 30. If I add together, I get 100, which means that this arc would be 80 degrees. Okay? Just because of 180 minus 70 minus 30. And then up here, this arc would give me 180 minus 70, which is 110. And just going to start flying through these now. MN, 70. 70 degrees. NQ is from here to here, 80 plus 30, 110 degrees. NQR, NQR, straight, that's 180. You can add these up, 30 plus 80 plus 70, it'll still give you 180 degrees. MRP, here's MRP, so it's 110 plus 70 plus 30, so 210 degrees. MR, here to here, 110. Oh, did I miss MRP? Oh, wait, I put MRP in the wrong spot. My bad. 210 degrees right there. Yeah, even I make mistakes. I know it's hard to believe. QR, right here, that's 70 degrees. QMR, we start here, QMR. Now you can do this 2 different ways. You can do 30 plus 80 plus 70 plus 110, or you see how that's just missing the 70? Just do 360 minus 70, 209 degrees. PQ, right here, 30 degrees given to you. PRN, PRN, it's everything but this 80 degrees. So 360 minus 80, 280 degrees. And then MQN, MQN, everything but 70. There's another 209 degrees. Okay. So we took a lot of look at arcs here. Hopefully this made a little bit of sense. Again, feel free to rewatch the video. And as always, this video is not the end-all be-all. If you do not understand something, please feel free to ask in class. I'd be more than happy to sit down and help you guys out. Okay? And as always, good luck. We're all counting on you.